Welcome to Study Loop.
Okay, let's begin solving problem 50. So, the basic idea of this problem is you are going to design gratings to make the experiment of the diffraction for the visible light. So, for the basic knowledge of the visible light, we know that the lower limit of the wavelength of visible light is violet light, and the wavelength of violet light is 380 nanometers. And for the upper limit of the spectrum, the wavelength of the red light is 750 nanometer. And we suppose the distance between each slit on the gratings is d, and d equals 1 over n. What's n here? N is the number of the slits of each unit length. Here is actually originally it has a unit. The unit is actually the per meters. Okay, so and the next is this to solve this problem it addressed to the relation between the first order diffraction angle of the red light and the violet light. The difference between those two angles equals 27 degrees. So the question is, what will be the number n here? I'll say for each centimeter, in each centimeter, how many states we'll find on the gratings. And so next problem is B. It asks, okay, so suppose we have the first order of the diffraction for the spectrum. Then what will be this spectrum begin? I mean, where it will begin and where it will end, at which angle. So basically, we are going to find the angle for the first order diffraction of both the red light and the violet light. And to solve this problem, it addressed to the formula 3617, which said the distance d times sine theta equals m is an integral number, times your wavelength of light, lambda here. And for our first order diffraction, actually we are going to solve the sine theta 1, which means here m equals 1. Okay, so basically if we write it in specific equation, it will be something like this. 1 over n times your sine theta equals 1 times lambda here. And lambda here could be your violet light wavelength or the red light wavelength. And we also plug in the relation between theta v and theta r. Recall that theta r minus theta v equals 27 degrees. So we can write the sine theta r into sine theta v plus 27 degree. So if we plug in the value of the theta v, which is 380 nanometers, and theta r, which is 750 nanometers, we will get this relation. Sin theta v plus 27 degree divided by sin theta v equals 750 divided by 380. So we can expand this, and we find that to solve that equation, we can solve the cotangent theta v here numerically. And so after we get the value of cotangent theta v, we'll get the value of theta v equals 30.38 degree. So we also get theta r equals 57.38 degree. And then we go back, find the relation between our sine theta and the number n here. We'll get that the n equals sine theta v divided by lambda v, which equals 1.331 times 10 to 6 per meter. But the problem itself asks us how many sleeves will find in per centimeter. So we change the unit to per centimeter, and it equals 1.31 times 10 to 4. It's almost actually 13,310, right? Okay, that's all for this problem. Thank you.